At first, the concept of an unfair machine learning model may seem like a contradiction. How can machines with no concepts of race, gender, ethnicity, or religion actively discriminate against certain groups? But we've seen example of models that are unfair. Actually measuring fairness is straightforward, but understanding why a model is unfair is more complicated. In a previous video, we looked at different sources of bias in data that could lead to an unfair model. These were historical injustice, proxy variables, and unbalanced samples. In this video, we're going to walk through an exploratory fairness analysis that attempts to quantify these sources of bias. I want to get the idea across that assessing fairness does not start when you have your final model. It should also be part of your exploratory analysis. By the way, if you want the Python code for these methods, make sure to check out the article in the description. It forms part of a larger analysis that also involves measuring fairness in models. Also, make sure to wait until the end of the video where I explain how you can get access to a Python SHAP course, a package used to understand and explain your models. So, we'll be exploring the adult dataset. This contains features like a person's age, their occupation, and the number of hours worked per week. We want to use this to try to predict if a person's annual income is above or below $50,000. We take above 50,000 as the positive prediction and below 50,000 as the negative prediction. And we'll say a decision is made based on this prediction. That is, if we make a positive prediction, a person will receive a loan. Otherwise, they will not receive a loan. Finally, we'll consider race and sex as our protected features. We want to understand if there's any bias in the data that may have a negative impact of the groups represented in these features. We can start by looking at a population breakdown based on the protected features. The first chart shows that 86% of people in our dataset are white. The second shows that 68% of the population is male. Clearly, we are dealing with an unbalanced dataset. The issue with an unbalanced dataset is that the model can become skewed towards the majority. For example, trends can be very different for male and the female populations. By trends, I mean the relationship between the model features and target variable. A model will try to maximize accuracy across the entire population. In doing so, it may favor trends in the male population, and as a result, we'll end up with poorer performance for the female population. Before we apply other algorithm fairness methods, we'll reformat our protected features as binary variables, where 1 represents a privileged group and 0 represents an unprivileged group, where the unprivileged group will have faced some historical injustice in the past. This is a convention common to a lot of algorithm fairness research. So going forward, for race, we'll define the protected feature as white for the privileged group, and for sex, we'll define male as the privileged group. Now, let's see how we can use prevalence to quantify historical injustice. For a target variable, prevalence is the proportion of positive cases to overall cases. Our dataset has an overall prevalence of 24.8%. That is roughly 1/4 of the people in our dataset earn above $50,000 and should be given a loan. We can calculate prevalence separately for the privileged and unprivileged group. Notice how the values are higher for the privileged group. In fact, if you are male, you are 3 times more likely to earn above $50,000 than if you are female. We can go further by calculating the prevalence at the intersection of the protected features. The top left corner gives the prevalence if you are in both privileged groups. Similarly, the bottom right gives the prevalence if you are in neither privileged group. This tells us that white males are over 4 times as likely to earn above $50,000 than females of another race. At this point, you should be asking yourself why we see such large differences in prevalence. This dataset was created using United States Census data from 1994. and the country has a history of discrimination based on race and gender, and the target variable reflects this discrimination. Another way we can analyze potential sources of bias is by finding proxy variables. Proxy variables are model features that are highly correlated or associated with protected features. A model that uses proxy variables could effectively be using protected features to make decisions. We can find proxy variables to a similar way of how you find important features during feature selection. That is, we use some measure of association between the feature and target variable. Except now, we just replace the target variable with our protected features. One metric is mutual information, which gives a measure of nonlinear association between two variables. It tells us how much the uncertainty around one variable is reduced by observing another. For example, we see that the mutual information value between marital status and sex is high. This suggests a possible relationship between these variables. In other words, marital status could be a proxy for sex. Another approach we can take is to build a model using the protected features. That is, we try to predict the protected features using the model features. We can then take a feature importance score as our measure of association. Another result of this process is that we have the model accuracy. This can give a measure of the overall association. The accuracy was 73% for race and 79% for sex. This suggests that proxy variables may be more of a problem for sex than race. So, we have seen that the dataset is unbalanced and that prevalence is higher for the privileged groups. We've also found some potential proxy variables. However, this analysis does not tell us if our model will be unfair. It just highlights some potential issues that may lead to an unfair model. In the next video, we'll build a model and show that, using different definitions of fairness, that its predictions are unfair. In the end, we can revert back to this exploratory analysis. That is to help explain exactly why we end up with unfair predictions. Related to fairness is the concept of interpretability. And if you want to understand and explain your models, then look no further than the Python SHAP package. My course will teach you both the theory and application of SHAP. And for a limited time, you can get free access if you sign up to the newsletter in the description.